Q scintilla, and then just download our stuff and it works. We've been trying to keep everything that we need packaged in with it. There's just a few things that we don't, but this is the list. It's up right now in Google Code. We will eventually have packages, so for those of you on Mac and Linux and Windows, it's easier for you to just download it and run it. And please, so how many of you are web application testers like us? Show of hands. Rough? Okay. How about functional testers of things that might use tools like this for security? And a couple more? Okay. So everyone
who knows how to write documentation?
We need those guys too.
You're on.
So all you guys that are testers, whether it's functional or application, your specialty is telling developers how much their software sucks. So we need your help in telling us bug reports on what goes wrong, and then hopefully some help on how to fix it too. But even if you just tell us what went wrong, that'd be great.
Yeah, you're probably going to want to wait like a week or two so we can get back from Vegas and fix some of the problems that we found while we've been out here. We're like 12th hour development, like running down, 10 minutes before we had to present writing code. So, that's the way it goes.
Yeah. We presented at Black Hat and we didn't see the outside of our hotel room pretty much the whole time.
Okay, so now we're on to the analysis engine, right? It's obviously in the title. This is a big portion of Raft. We wanted something that would actually analyze everything that we currently had, right? I don't want to have to spider the site again to figure out if there are comments that may, have some data that are interesting. Yeah, I can go back through the burp state or whatever, but it's, you always find yourself writing another manual tool to pull more data down. But if I've already got all that data, let's actually just analyze what's there. So our model here for analysis is something modular, right? We want to be able to, write one time and have it analyze all this data that we have. We want to be able to analyze sessions as a whole, not just single request responses. If the first request is different from the last request, but we made the same or the responses are different, but we made the same request, we want to know that and we want to know why. So we want to find what others ignore. We want to look at timings, like how long it takes a page to respond. We want to do some image analysis. If you guys have looked at Google Images lately, they now actually pull out EXIF data and will display where exactly an image was taken or what camera was used for it, that type of information. And that's not something you typically look at during an assessment, but it could be useful information, especially for a social engineering engagement, something along those lines. So the possibilities are really endless. These analyzers are extremely easy to write. Let me show you at least the demo, right? I guess we've got anal going on right now, but right now there's nothing in the analyzer. We haven't run the analysis or the analyzers yet, but we are looking at actually hooking some of the scanner and fuzzers into the analyzer, so it would kick off specific analyzers when we make a request and things like that. But currently we have to actually click this circle button up here which runs the analysis, and we get back, in this case, 120 results. Now these analyzers, this is currently what we've written. Some are in flux, some do more than others do. We've got, we're looking for error messages, insecure cookies, the low-hanging fruit, what's currently out there. We're analyzing some redirects to see if there is more information behind a redirect than is actually displayed to the browser. Your browser takes a redirect and just takes you to the next page, but I've seen applications where people actually allow you to spider the admin section because the developers didn't write the redirect portion of the application correctly. Timing analysis.
Yeah, thanks a lot, PHP developers.
Yeah, you're right on, man. The timing analysis, looking for the denial of service pages, anything that would cause the server itself to spin longer and to take up more cycles so we could, potentially execute a denial of service attack. So these are ones that we've currently written. If you've got other ideas for what can be implemented, let us know. We did implement simple regex and strings. So all you have to do is change the configuration, add your regular expression that you want to look for in all of these requests, and it'll display them to you. So currently I think we've got, we're looking for personal information. So in Altero Mutual, it found some private information here, a phone number, and it'll actually tell us, let's see, in the response, I believe. Yeah, so it finds the phone number and it'll show it to you, so it's easy to scope through there. And I think when we were building this, we decided, hey, we want to know if XSS has been found. It took us all of 20 minutes to write the XSS finder to see if an alert box popped, and if it did, then if it was in the request, then XSS is obviously within the application. So, and we'll do an example of that in just a minute. Yeah, so that's the analysis engine. Jump back over to Keynote.
So a little bit about our smart testing components, because we basically so far we've been talking about data you've already collected. So now you've already collected the data, you want to do some additional testing based on the data you've collected. So we created a requester and a fuzzer, and those are templatized, and we'll get into those in a second. We're about to do the demo. But we also have the ability to run sequences. So you can launch the sequence builder, build your sequence out, and then import it into, or just select it from the drop-down box when you're doing your testing. And of course, we have a browser object, so that browser object can be utilized during the testing as well. Oops. Oh, yeah. So this templating approach is probably better just to show you versus explain about it. So we'll go through a simple example of using the templated approach to fuzzing. So we're going to grab our URL here, make a request for the resource.
So we want to actually replay this request first. So we're just using the OWASP broken web application. We know that this is vulnerable to XSS, so it's a good place to test.
Yeah, and we're using our own built-in web browser, so any of the requests that you make through here end up in your data set automatically.
So here's the request that I just made, the name equals test. Easy enough to send that over to the web fuzzer.
And as you can see the templates here, so there's some automatic templates, but there's a payload drop-down box for where you want the payload to go. And here's the mapping screen. So you can map payload names to different sources. Yes, the two in there are hard-coded. That will not be hard-coded for long. We needed something for the demo. So we'll have a directory where you can load all your favorite lists, and those will be automatically available to you in the interface. So go ahead.
Yeah, so in this case, I need to fuzz the name equals test variable. So I'll add the marker just there at the end of the URL.
This will be explained better in our documentation, so because we're working this out right now. So
our copious documentation at this point.
yes.
All right, so all we have to do is start the attack. You see it went really quick. Again, these are hard-coded lists. We have, it's not everything and anything. But you can actually view the results, what it did, all of them that it sent. So if we're looking at, let's see, yeah. So you can look at each of them separately, or we can go back and look at them in the response view. Now at this point, we've done these tests. We want to see if it found any XSS, so we're going to run the analyzer again. And now we have, instead of 120 results from the first run that we did, we've got 162. And all those are in the XSS finder. And it looks like we've got a couple here. If I actually render the page and it was successful, I get the XSS pop-up because I am rendering it. I mean, we're actually running the WebKit engine behind the scenes.
Okay, so we're going to have a sequence fuzzer, and we were looking at his laptop. It's kind of funny because it locked on us, so we don't know where we are. So we're going to have a sequence fuzzer, and that sequence fuzzer is going to allow you to tag data in sequences. We call it dynamic data replacement. So you can import a sequence of events, tag that CSRF token, that elusive CSRF token that's making all of your requests fail. You can tag that and then place it into your payload. So now all of those previous tests that you were running that were failing will now become successful. And in the future, we're going to have the ability to do any kind of dynamic data on the DOM. So the really difficult to test applications, you'll now have visibility into doing those without having to do them by hand.
Yeah, so I'll just do a quick sequence builder demo. This is obviously not completely functional yet, but at least give you an idea, because we're still in the process of getting our dynamic data replacement features to work So here we have a pretty typical login form. We'll just log in, foo-foo. And as that's submitting, we should start seeing cookies getting captured. If that ever comes back, we'll see the parameters.
The network is down. Oh, wait a minute.
Yeah, the
we're not on
network is down. Yeah, the local network. And we're in bad shape. But you can come through here, and by default, any sort of media responses are excluded from sequences. This is where you configure the dynamic data replacement. We're going to offer the ability to run the sequence in a web browser, so you can literally render the whole thing. We discussed earlier about some of the session state problems. So we offer both an in-session pattern and an out-of-session pattern, so that you can figure out, well, do I have some specific request that's causing a problem? So let's see. I think I'll log out. Log out. Yeah.
People that are leaving are going to be really upset because we're giving away free cookies.
Yeah. What am I looking for here? Log in, log out.
Is it sign out?
Yeah, could be. No, it's log out. All right. So if you've configured other tools, sometimes it can be a pain to figure out. So we actually search through it dynamically and mark it up for you. Yep.
So how many people in here would like to search for DOM-based XSS without having to use a browser plugin or having to send your website to some application off on the web and have it test? Anybody? That should be pretty much everybody. So we have a built-in DOM fuzzer, so it's integrated into our tool so we can identify things like DOM-based cross-site scripting without you having to use another tool. We're going to do a demo of that right now.
So I have imported a couple of web pages that are, I know, vulnerable to DOM-based cross-site scripting because I wrote them. And I'll show you the response here. So if you look in the response, it just does a simple, let's zoom this out a little bit.
This resolution is
It's just killing us.
Yeah.
So it's just doing a document.write location.href, so that's going to be vulnerable in some circumstances. This one is also doing something similar. Yeah, this is doing an unescape. So if you come over, our DOM fuzzer is very basic, but it still finds stuff. So if you look at these tests, we've generated some unique script statements. Those are quite common. An alert that would go into a string if you were doing a string, and as a pattern that's going to be pretty much unique on the page. So what we'll do is we'll go through and run the fuzzer based on the oops.
That is the absolute first time that that's happened.
Yeah.
I swear. That sounds like a joke, but it is the first time it's ever done that.
Mm-hmm.
So I guess we need to fill out some bug reports
Yeah,
ourselves.
I guess so. So what this is doing is it's taking the saved HTML data and it's loading it into an instance of WebKit, and it's setting the base URL to the modified value. So this is not making any sort of network requests at all, but it's still replaying those values and rendering it as if it was on the original site. So we should start seeing some results coming through, and we're doing a couple of matches here. The first one is high. We hook the alert box, so if we see an alert box pop up with that number in there, we say, bang, found some DOM-based cross-site scripting. In other cases, we're just looking for pattern matches in the rendered DOM content. So like if we look at this guy, you can see that's written out, and if we render it, boom, right there. So we found DOM-based cross-site scripting without sending any network traffic at all. And are we? Yeah. Okay. So this we have screenshots of in our presentation, but I'm going to try it. If this works.
Uh-oh.
Yeah.